this lecture I am going to discuss the concept of image enhancement. The technique here I am going to discuss is spatial filtering. The main objective of this enhancement is to improve the interpretability of the information present in the image. You see the classification of image enhancement. There are two important techniques. The first one is spatial domain method and the second one is frequency domain method. In spatial domain method, the operations are directly performed on the image itself. But in the case of frequency domain method, the operations are performed on frequency domain representation of the input image. There we may use various transformations which are used to transform the input image into frequency domain. The spatial domain methods are point operation and mask operation. In point operation, the operations are directly performed on the pixels, but one pixel at a time. But in the case of mask operation, we are going to consider the neighborhood of pixels present in the input image. Let us see the operation of this mask. This slide shows input image, output image, and if you see the transformation expression g of x comma y equal to capital T of f of x comma y, where T is called as operation which performs the operation on neighborhood of the selected pixel present in the input image. After the operation, the value replaced with the pixel in the processed image. The first important spatial filter is smoothing filter. The smoothing filter is also called as mean filter, averaging filter, low pass filter. The smoothing filter comes under linear filter. Here we are going to use filters. There are other names for filters: masks, kernels. These kernels are used to perform the smoothing operation. This slide shows two filters. The first one is box filter. In a box filter, all the elements in the filter are equal to 1. The second one is weighted average filter. In weighted average filter, the all values may not be equal to 1. The main advantage of the smoothing filters are noise reduction, smoothing of false contours, reduction of irrelevant information present in the image. But the main disadvantage of the smoothing filter is it blurs the image. That is the main drawback. To eliminate this drawback, we are going for weighted average filters. These weighted average filters reduces the blurring in the smoothing process because of non-equalness of elements present in the filter. Here we will perform the convolution operation in this mask operation. The second type of smoothing filter is median filter. This median filter comes under non-linear filter. You will see the task performed by the median filter. The first one is all pixels in the neighborhood of the pixel in the original image which are identified as the mask are sorted in the ascending or descending order. After this, the median of the sorted value is computed and is chosen as pixel value for the processed image. The main advantage of this median filter is it can eliminate the salt and pepper noise present in the input image. The salt and pepper values are corresponds to the very high level gray levels and very low level gray levels present in the image. Because of this median operation, those very high levels and very low level values are eliminated. That is the application of median filter which eliminates the salt and pepper noise. The next category of spatial filters are sharpening filters. The sharpening filter comes under high pass filtering. The main objective of the sharpening filter is it is used to highlight the fine details present in the input image. The fine details may be points present in the image, lines present in the image, and edges present in the image. It is simply opposite operation to the smoothing filters. Here in smoothing filters, which perform the blurring of the image, but in sharpening filters, all fine details are highlighted. All other things are eliminated. There are requirements for digital derivatives. Here we are going to use first order derivatives and second order derivatives to perform the sharpening operation. If you see the first order derivative requirements, the first order derivative must be 0 in flat segments, must be non-zero along ramps, must be non-zero at the onset of gray level, step or ramp. Second derivative requirements are the first one must be 0 in flat segments, must be 0 along ramps, must be non-zero at the onset and end of gray level, step or ramp. Here, to implement these operations in spatial domain, we are going to use gradient operation to implement the first order derivative, Laplacian operation to perform the second order derivative. Let us see the first order derivative, which is called as gradient. Here we are going to use the magnitude of the gradient to perform the sharpening operation in spatial domain. These are the corresponding mathematical expressions which are used to perform the gradient operation. There are wide number of gradient operators are possible, like Robinette operator, Sogel operator, and so on. Let us see the second order derivative, which is called as Laplacian. These are the mathematical expressions we will use to perform the Laplacian operation. Mostly we will use second order derivative, which is Laplacian, to perform the sharpening operation in spatial domain rather than first order derivative. Here in this lecture we have discussed smoothing spatial filters as well as sharpening spatial filters. Smoothing filters perform the smoothing operation, sharpening filter perform the sharpening operation, which is nothing but highlighting the fine details present in the input image. This is the end of the lecture.